Welcome back. Today in this video I will be trying to tell you about matrix operations and along with that some more things. So basically, as you know, matrix has elements. It can have number of rows and number of columns. If it has single row or single column, we can also create that in the MATLAB. So if you are having a single row, this is how it should look. So let me tell you how to do that. So say A equals to square bracket 1, either you can put semicolon or space 2 space 3 and let me close bracket. Then I will get a matrix 1 2 3. I can check this. You can have a look. I have a 1 cross 3 matrix with 1 2 and 3. Before I go further, some students or someone who is using it for the first time, he forgets to use space and he says this is 1 2 3 without space. Then what will happen? Let me enter. Then it creates only one element of 1 cross 1 matrix instead of 1 cross 3 matrix. Hence you will get only one element, that is 1 2 3. So this is entirely different from previous one where we had created 3 elements of 1 cross 3 matrix with element 1 2 and 3 and not 123. Okay. Now if you want to create 2 rows, then I just have to put a semicolon and say 4 5 6. Let me enter. So now I have matrix with 2 rows 1 2 3 4 5 and 6. That's it. So now if I am interested to create only one column with values 1 2 3, in such case between 1 and 2 I need a semicolon, between 2 and 3 I need it. So this is only one element of first row. Then I go to the second. Semicolon basically tells you are going to the next row. Then next row after 2, then let me enter. You get 1 2 3 and you got, you can check 1 2 and 3. That's how you can get to know whether you have entered this or that. So now let's go to the next content. So we have seen these two. Now before I go here, let me go to important this aspect where if I want to create a matrix A, say starting with 1 up to 10, say 1 2 3 4 5 6 7 8. Now it's tedious job. You know, there is an order in it. Can we not have something to create on its own? So instead of saying 1 2 3 4 5 6 7 8 9 10, this is one way of creating. Of course I have created 10 elements. Other way, in case say I have to create 100 elements, it becomes very tedious. I can use 1 colon or is to 10. If I say this, I get the same thing but in a much shorter way. Now this is also equivalent of 1 is to 1 is to 10. There are 3 components here. One of the component is hidden, that is 1. By default, if you don't mention anything, if you just mention first element and the last element, the middle element is assumed to be 1. If you mention middle element, it will take that value. Right now I have taken 1 just to show you that earlier values and this value is same. Let me modify that 1 to 2. Now what do you see? So after 1, instead of getting 2, you got 3. What it says, the middle element is basically the increment. After 1, you add 2, you get 3. After 3, you add 2. After 5, you add 2. After 7, you add 2. After 9, if you add 2, you get 11, but the last value is 10. So hence, you can't have the next value. So I can even make this 0.5, then you will get 1, 1.5, 2, 2.5, and so on up to 10. This is how you get. Now, why I said this in before I continue, because we will be using this. Okay. Then another important thing, anyhow, this is related to how do we create the points. Say I want to create, here you know initial value, final value and increment. Say I want to create a number of points, say I want 100 points between 0 to 10. I know initial value, I know final value, I know how many points I want in between them equally placed, but I don't know what is the increment. Then I can use a function called Linspace, which is linearly spaced. Okay, I can just for time constraint I am just copy pasting, you just have to type it. So remember, it's not a square bracket because it's a function. So when you go with Linspace, you have initial value as 0, final value as 20 with 5 points. 1, 2, 3, 4, 5 points. That's what you get. And then if I go to the next one, it's a log space. Now first let me show you the difference. Now when I say log, basically it is to the base 10. When I say log space, it is 10 to the power 1 to 10 to the power 5 with 3 points. So 10 to the power 1 first point, and 10 to the power 5 last point, and totally you need 3 points. So you get 10, 1000 and 1000, 10 to the power 5. So you get 3 points equal space in log space. Okay. Now many of you may ask what is log and linear space. To give an example, let me show you the graph that you might have used. Most of you might have used this linear graph. So here you can see the independent axis and dependent axis, which we generally call x and y. The x-axis is 1, 2, 3, 4, 5, and y-axis also 1, 2, 3, 4, 5. This is very obvious, which we have used. This is called linear because between 0 to 1 you have one distance. Similarly 1 to 2 you have same distance. So there is both the sides there is linearity. So we call it as linear space. Now if you have a frequency, say I am trying to capture amplitude of my voice on a graph, then I have a frequency from 3 Hz to say 30 kilohertz. Then along x-axis I need a frequency component from 0 to, or 3 to 3 Hz to 30 kilohertz, which is huge value on x-axis. But whereas y, it could be linear, so which is say in the order of 0 to 10 or 0 to 20. So at one axis you have a huge data set, and another axis you have very small data set. In such cases it's very difficult to plot on linear scale. In this kind of situation, the x-axis, if you plot using logarithm scale, after 1 you don't get 2, rather you get 10. After 10 you get 100. After 100 you get 1000. So it will be this distance which is incrementing by 1 will be incremented by logarithm scale. So after 3, the next thing that you will get will be into 10. So it will be multiples of 10. Hence you get a huge data sets which is possible to be implemented on the scheme scale. For example, if I start with 0.1 hertz, next is 10 hertz, 100 hertz, say 1000 hertz, then 10,000 hertz, then 100 hertz, sorry, 10 to the power 4, and so on. So thereby I can represent everything in a small space. This is called semi-graph. Let me show you that SEMILOG. So why it is called semi? Because one axis, that is the x-axis, is logarithm scale, whereas the y-axis is linear scale. Now you can see, you can start with 0.1 or 0.01. It is just for your demonstration. If you start with 1, then you get 10, then 100, then 1000, then 10,000, and so on. Now between this, you can see that there is a huge space, and then there is small space, and this space reduces. So 1, 2, 3, 4, up to 9 and 10. After 10 you get 20, 30, up to 90, and then 100, then 200, 300. After 100 you don't get 110, you get directly 200, 300, 400, then 900, then 1000, and so on. Sometimes while drawing a graph, you tend to keep it inverted, which is wrong. See, if you are plotting from this side, if it is you consider this as 1 and this as 10, you can see that this difference is very small. You have kept it in the wrong direction. You have to start from this end, so right to left, like Arabic. So it's better you change it, tilt it over, and keep it in the right direction. So always see that the left corner is something like this, where you get a huge range. Then it decreases. So this is the right way. Now this is called SEMILOG. Now you may ask, if I have huge values both in x-axis and as well as y-axis, then there are two possibilities. You can scale it and use linear scale, or you can use log scale, which is in both the directions along x and y, it is logarithms. So very rarely used, but yes, these are available. So it is in log scale in x-axis as well as log scale in y-axis. Whereas if you see the previous, it is only in x-axis it is log scale, whereas in y-axis it is equally distant, you can see. So it is linear and logarithm. So it is SEMILOG. Whereas this, we use both log. And here it is linear and linear. So when we are going for log space, basically we are working with, say, SEMILOG. Okay. When we are working with linear scale, we need linear graph. So you should be aware of which scale we are using in engineering based on our requirement. Most of the time when we are working with frequency domain, we will work with log scale. So most of the work will be in SEMILOG. So in general, when we have huge data set on independent axis and dependent axis, very linear graph, we go with SEMILOG graph. Okay. So now let's go with our remaining content. Okay. Now you understand this. Now let me try 1. Initially is 10 to the power 1, then say 10 to the power 6, and I need 4 points. Okay. So I have, okay. Okay, so as we can see here, when I type 164, I wanted 10 to the power 1, the last value is 10 to the power 6, and I needed 4 points. So between, this is a multiplying factor, so initial value is multiplied with 0. I think it's not exactly 0, but close to 10 to the power 1, that is 10. But when you multiply with huge number, you are having that small value. So there are 4 points, 1, 2, 3, 4. Okay. Now another example, 177. Here the first number is 10 to the power 1, then last number is 10 to the power 7 with 7 points, 1, 2, 3, 4, 5, 6, 7. So this is how we are working. Let me clear this screen. Okay, and let me clear all the variables. Clear all. Yeah, I'm done. Next point. So let me try to solve this. So I'll solve one or two. Remaining things you have to solve. Now let me see what is C. So C is written as, okay. So I have a matrix with 3 cross 3. If I want to select only one element, say first one, then I can say C of 1 comma 1. C has to be capital, yeah, 1. Now if I want 1 comma 3, which basically is third, so I would get 3. If I want the whole first row, I have to say C of first row, comma, which column? We don't know. So I would say starting with 1 is to 3, column is 3. So I will get all elements starting from 1, 2, 3. That's what it means. But if I know that it is all elements, instead of saying first and last, I can simply say colon. If I put a colon, it means starting number is first and the last number is last in a matrix. Hence, it will select 1 and 3 in this case. Okay, so it gives the same result. That's what is shown here. Colon means it selects all from first to last. In this case is 1 and 3 is the last. Okay, if I want in between 2 and 3, I can select. Okay, similarly you can check all of these and try on your own. Okay, here upper triangle matrix U, okay, lower triangle matrix L, so you can see it, you get only upper triangle. You can find diagonal, determinant, then transpose, inverse, rank, eigen. Remember, while finding inverse, you may not get inverse of all matrix. So sometimes it may say singularity error or something. So keep it that in mind, because determinant of that matrix may be 0. You are trying to divide it a matrix by 0. So you can try all this, and then if you want to perform matrix addition, you can simply go for A plus B, A minus B, A into B, A divided by B. All this will give you matrix addition, subtraction, multiplication and division. And then if you want to go with the last but one element, you can also use AND minus 1, which you can try. Then concatenation of matrix you can try. So if you want to concatenate A and B matrix, anyway you can try this. Let me show you. This is A matrix, this is B matrix. If I say concatenation, say D, let me copy paste for, you can check. Now this is A matrix and B matrix, this together is a D matrix. In the second case, there is semicolon, which basically says put the matrix one below other. So if I do that, this is A matrix and this is B matrix. So that's what is this. Then if you want to create a matrix with all zeros, all ones. Of course, you don't have function to create all twos, threes. You can use multiplication of a matrix and create anything that you like, but you need a matrix with all zeros or all ones, and this is random, which creates random numbers. And you can also check what ice does. Okay, and there is also magic. You can check what magic does, so you can go to help and see what it does. So of course there is a difference between this operation and period operation. If I want to do any of created A and B, if I try to do, say, A dot into 2, each element gets multiplied by 2. Now same thing if I remove the dot. Of course, in this case also each element gets removed. Now there are some operations like square. Say I want to do A, let me try this, A into A. In this I am multiplying each element of A with its own element. So it is basically, say, first let me see what is A. Yeah, A is this, and then I am multiplying A into A. So in a dot product, 1 gets multiplied by 1, 3 gets multiplied by 3, 5 gets multiplied by 5, and so on. So let me put that. So you can see each element is squared, but when you remove that dot, it's a matrix square, which is different from this. So you may require this kind of operation at different stage in your calculations. So this and this are different. This operator, period operator, does element by element, whereas this is applicable for whole matrix. In some cases you may have matrix operations same as element by element operation, but not all cases. Remember that. Thank you.
If you like this video, kindly click the like button below. Subscribe to this channel for updates on this and similar topic, and share the video with your family and friends. Kindly suggest the topic of your interest to be covered in the next videos, and also your point of view about this video in the comment section below.